Hello everyone, welcome to my channel. First of all, let me introduce myself. My name is Fahreza, and today I will get to present about my task in competition class where my lecturer is Mrs. Afia Hayati. So, I will summary one international journal from Thomas Fisher and Christopher that was published in 2017 with the title Deep Learning with Long Short-Term Memory or LSTM Network for Financial Market Prediction. So, this is for outline of this paper. First, introduction, and second, briefly covers the data sample, software package, and hardware. Third, provides an in-depth discussion of our methodology, such as the generation of training and trading sets, the construction of input sequence, the model architecture and training, as well as the forecasting and trading steps. And then presents the result and discuss about most relevant finding in light of the existing literature. And the last is conclusion. Long short-term memory networks are a state-of-the-art technique for sequence learning. They are less commonly applied to financial time series prediction, yet inherently suitable for this domain. This paper deployed LSTM network for predicting out of sample directional movement for the constituent stock of the S&P 500 from 1992 until 2015. Prediction tasks on financial time series are notoriously difficult, primarily driven by the high degree of noise and the generally accepted semi-strong form of a market efficiency. In the last years, initial evidence has been established that machine learning techniques are capable of identifying nonlinear structure in financial market data. Some studies use deep learning, random forest, gradient-based tree, and different ensemble as forecasting methods. One key finding is machine learning with return of 0.33% per day prior to transaction cost underperform gradient-based trees with 0.37% and random forest with 0.43%. In this paper, there are three contributions to the literature. First, focus on LSTM network for time series prediction on all S&P 500 constituents from this year, and contrast our finding to selected benchmark from the literature at random forest, the best performing benchmark, a standard deep neural network, to show the value add of the LSTM architecture, and a standard logistic regression to establish a baseline. It aims at shedding light into the black box of artificial network, thereby unveiling source of profitability. Generally, it finds that stocks selected for trading exhibit high volatility, below mean momentum, extreme directional movement in the last day prior to trading, and a tendency for reversing this extremely movement in the near-term future. It synthesizes the finding of the latter part into a simplified, rule-based trading strategy that aims at capturing the quintessence of the pattern the LSTM acts upon for selecting winning and losing stock. For the empirical application, it used the S&P 500 index constituent from Thomson Reuters. For eliminating survivor bias, first obtain all month and constituent list for the S&P 500 from Thomson Reuters from December 1989 to September 2015. Then, consolidate this list into one binary matrix indicating whether the stock is an index constituent in the subsequent months. As such, to be able to approximately reproduce the S&P 500 at any given point in time between December 1989 and September 2015. In a second step, for all stock having ever been a constituent of the index during the time frame, and download daily total return indices from January 1990 until October 2015. Return indices are calm dividends prices and account for all relevant corporate action and stock splits, making them the most adequate metric for return computation. Average monthly summary statistics for S&P 500 constituent from January 1919 until October 2015 split by industry. They are based on equal weights portfolio per industry as defined by the Global Industry Classification Standard Code, formed on monthly basis and restricted to index constituency of the S&P 500. Monthly return and standard deviation are denoted in percent. For data preparation and handling is entirely conducted in Python 3.5, relying on the packages NumPy and Pandas. Our deep learning LSTM network are developed with Keras on top of Google TensorFlow. Moreover, it makes use of scikit-learn for the random forest and logistic regression models and standard DeepNet. The LSTM network is trained on NVIDIA GPUs. All other models are trained on GPU cluster. Methodology consists of five steps. First, it split raw data in study periods, composed of training set for in-sample training and training set for out-of-sample prediction. Second, discuss the feature space and target necessary for training and making prediction. Third, provide an in-depth discussion of LSTM network. Fourth, briefly describe random forest, the DeepNet, the logistic regression model that was applied for benchmark model. 5. Develop the trading approach. The rest of the section follow the 5-step logic outlined above. Define a study period as training trading set consisting of a training period of 750 days, approximately 3 years, and a trading period of 250 days, approximately 1 year. Then split entire data set from 1990 until 2050 in 23 of this study period with non-overlapping trading periods. In other words, the study periods are rolling block of 1000 days. Training is done with rolling windows on the first 750 days. For example, by rolling a lookback input of 240 days across the block and then predicting 1 day ahead. Trading is performed with the trained parameter on the last 250 days fully out of sample. Then the entire system is rolled forward by 250 days, resulting in a total of 23 non-overlapping trading periods. This is for the future generation. Let's say P as T and T element of T be defined as the price process of stock S at time T, with S element of 1 until Ni, and RMST the simple return for a stock S over M periods. For example, this is the equation. And the for LSTM network, first calculate 1 day M equal 1, return R1 SG for each day T and each stock, and stack them in one large feature vector V of dimension N Y cross T study. Then it standardizes the return by subtracting the mean and dividing them by the standard deviation obtained from the training set. This is for target generation. Order all one period return of all stock S in period T plus 1 in ascending order and cut them into two equally sized classes. Class 0 is realized if the one period return of stock S is smaller than the cross-sectional median return of all stock in period t plus 1. And for the class 1 is realized if the one period return of S is larger than or equal to the cross-sectional median. So this is for the LSTM network. The long short-term memory network is a variant of the standard recurrent neural network. By replacing the basic hidden neuron with LSTM unit in RNN, LSTM network can better handle the problem of gradient vanishing and explosion of long-term dependencies. The detailed structure is shown like this picture. For a basic LSTM unit, there are 3 gate controllers are placed into the LSTM unit, namely the input, 4 gate, and output gate. The 3 gates are mainly used to determine what information should be remembered. The LSTM network implements temporal memory through the switch of the gates to prevent the gradient vanishing.